In this video, we're going to go through 3 ways on how we can prove that two triangles are similar to each other. So not congruent, but similar to each other. So there's 3 reasons. So first off, we're going to remind ourselves congruent triangles can be proven when we have congruent sides and congruent angles. And the different ways we can do that is by side, side, side. We then did SAS, side, angle, side, HL, or hypotenuse leg, angle, angle, side, and then angle, side, angle. So that's all for congruent triangles, not similar triangles. So next, we're going to use similar triangles. And also I want to point out the symbol for congruent is right there, and here is the symbol for similar. So it's just the squiggly part above the equal sign. So in similar figures, parts of them are going to be congruent and parts are not. So the angles are still going to be congruent to each other, but the sides are going to be proportional. So in other words, when we say the sides are proportional, that means that the ratios need to be the same between the side setups. So these triangles can be proven similar using angle, angle, side, 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 and side, angle, side. So I'm putting the little similar symbol right after it so that when you see that, they remember that we're dealing with similar triangles and not congruent triangles, especially our SSS and SAS, because those are the same repeated ones from up here. So the first one for angle, angle, so AA, is if we have 2 angles in one triangle that are congruent to 2 angles in another triangle, then the 2 triangles are similar. That's the symbol for similar also. So, and the reason for that is because once we have 2 angles that are the same, if we have those 2 angles, we can subtract from 180 to figure out the third one. So really, all 3 angles are going to end up being the same size. So when we list out the letters down here for the similarity statement, we need to go in the same order. So J is first. So the angle that's congruent with J is X. Next is K. So the angle that's congruent with K is Y. And lastly is L, so the angle that's congruent to L is Z. And that's our similarity statement. One type of question you're going to see is we're going to give you 2 triangles and ask you if they're similar or not. So for this one, if you notice you have 2 angles, we need to figure out what that other third angle is going to be. So remember, if we subtract the 90 and the 26 from 180, that would give us the remaining angle, which is 64 degrees. So angle E is 64 degrees. We're going to do that with this other angle as well. So 180 minus 90 minus the 64 in this triangle gives us 26 degrees. So now you can see that all 3 angles do match up and they are all congruent. So yes, triangle CDE is similar to triangle KGH because of angle, angle, similarity ratio, and that's when 2 angles are congruent. Sorry about that noise in the background. That was Mr. Douglas sanding some things in the garage. So for this next one, you can see that we really have 2 triangles in one. So there's one large triangle and there's one small triangle. So I strongly recommend that you draw out the 2 separate triangles. So I've done that myself, and if you notice, angle A, both of those triangles share that. So angle A is congruent to angle A, and if you notice, that is a reflexive property again. It's just with angles instead of sides. So with that, we can see that we have 2 angles that are congruent. So yes, the 2 triangles are similar to each other. So triangle ABE is similar to triangle ACD, and our reason why is by angle, angle similarity again. So for this last one, if you notice, we do have some parallel lines in there, and if you remember from before, we're going to have these alternate interior angles are going to be congruent, and there's actually 2 sets of them. And we will also have our vertical angles in the middle, and they are also congruent. So if you notice, really all 3 angles are the same, so because of that, these 2 triangles, we can say yes, the triangle SRV is similar to UTV by angle, angle similarity. So just like we did before for congruent triangles, you do need to line up each of the letters together. The next reason why we can prove the two triangles are similar is by side, side, side. So if all three side lengths of two triangles are proportional, which remember that just means that they have the same ratio, then the triangles are similar. So if you notice down here, it does compare the red triangle sides to the blue triangle sides. So AB with RS, AC with RT, and then BC with ST. And if we look at all of those ratios, they will all come out as the same number. So that ratio, remember that number is the scale factor. So in this question right here, we want to see which of these two triangles is similar to this one. So what we need to do is we need to check each of them. I want you guys to push pause and write down what I just wrote right here. So you need to line up the smallest sides together, then the medium, and then the largest sides together. And if you notice, they're color-coded on mine, but on your own paper, you're not going to be able to see that. So the smallest is right here with my 8. In this triangle, the smallest is my 6. In the last triangle, my smallest is my red, the 8. Then the largest is my 16, the 12, and the 16 again. Then our medium is the 12, the 9, and the 10. So when we set up our ratios, we're going to be using those the same way. So first we want to set up the smallest. So I'm going to check the triangle right here against triangle DEF. So I'm going to put my large, so 8 over the smaller one, and check to see what that reduces to, and that would be 4 over 3. Next, I'm going to do the medium size. That would be 12 over my 9. Remember, it's easier to see when it's in color, so you could color code it as well on your paper if you wanted to. And that also gives me 4 over 3. Then for my blue, I have 16 over 12, and that also reduces to 4 over 3. So since they are all the same, then that means that this triangle is similar to the first one. So let's check the last one the same way. So we're going to line up the small, the medium, and the large sides. So for my small sides, I'm going to have my 8 again, and this time it's over the 8 in this triangle, and it reduces down to 1. My medium is 12 in the triangle on the left, and in this one I have a 10, and that reduces then to 6 over 5, so not quite 1. And then for the blue, I will have 16 over 16. That reduces to 1, but they're not the same, which means they are not similar to each other. In these two triangles, we want to find the value of x, and when we know, or to make it so that they are similar to each other. So what we want to do is line up the corresponding sides. So my 4 is going to correspond with my 12. My x minus 1 corresponds with my 18, and I'm color coding this also. And my 8 corresponds with my 3x plus 1. So the part that I notice is that my 4 and my 12 are my numbers. So I have actual numbers for those, so that's how I'm going to set those up. And then I need to use one of the other colors. So either I use the green or I'm going to use the red. So I'm going to use the green. So notice I did this triangle first and then this triangle second with my ratio, which it really doesn't matter as long as you keep it the same. So I'm going to do my 18 on top and then x minus 1 on the bottom. When I cross multiply, don't forget to distribute the 12. So that would mean that I am going to be multiplying my 4 times the 18. So we get 12x minus 12 equals 72. When I move my 12 over to the other side, I end up with 84 equals 12x, and I get x equals 7 when I divide that. So one thing you can realize is that if you set it up a different way, if you did your 12 over 4, and instead I wanted to use my red, I would do my 3x plus the 1 over 8, and I will still get x equals 7. So it doesn't matter which way you get your ratio set up, you can get the same answer even if you use a different pairing. So for the last way to show that two triangles are similar is by side angle side similarity, and this one starts out if we have an included angle of one triangle and it is congruent to an included angle of a second triangle. Remember, the angles are congruent, and that's okay. Then the side lengths surrounding the angles are going to be proportional. So if you notice, my angle X and M are congruent, but I'm not going to make any congruent marks on my triangle surrounding them. But if you notice, the XZ is right here, and that's proportional to M piece, the same ratio. And XY over MN is also the same ratio, so they're equal to the same ratios. And that's by side, angle, side. So to see how side angle side works in an actual picture, we see these two triangles in this little lean-to that this person was making while camping. And so if you notice that these two angles right here are congruent, and it is the included angle, so we've got the angle part of it for this side angle side. So we put a little check by the A. Next we need to make sure, or really check on both sides of that angle of the 53 and see if the sides compared to each other make the same ratio. So for the first one, I'm going to do this in blue. So 6 and my 9 are the corresponding sides. I'm going to check to see if 6 feet over 9 feet reduces to the same ratio. And the feet cancel out, but the 6 over 9 reduces to 2 over 3. Next, I want to check the 10 and my 15 the same way. So I need to do my 10 over 15 feet for both again. My feet cancel, and my 10 over 15 does reduce to 2 over 3. So if you notice, they are the same ratio. So that means up here, I can put a check by both of the S's. So both of these sides surrounding that angle are proportional to each other. So we can say that yes, our triangle GFH, the one on the left, is similar to the triangle BAC, so in that same order, by side angle side similarity. So now with all three types of triangles mixed together, we want to check to see which triangles are similar and which ones are not. Tell me the reason why they are similar. So either AA similarity, we have side 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 similarity, or you have side angle side similarity are your different reasons. And then if they are, you want to also write a similarity statement, so stating which triangles are similar to each other. So in this first picture, we need to find out what this missing angle is. So if we take our degrees again and we subtract them from 180, we end up with this degree is 31 in my triangle. If I do the same thing in this triangle and I subtract my 41 and then 82, I end up with a 47 degrees. But now if you look at all three angles inside the triangles, that none of them are really the same other than the 52, or the 92, sorry. So one angle is congruent, but we do not have two. So these are not similar triangles. All right, so moving on to the one in the upper right. We know our vertical angles will be congruent, and we need to pair up our corresponding sides to figure out our ratios. And I just wrote a little side comment, so make sure you're pairing up these smaller numbers together. So that would be my 9 and my 15 are the smaller numbers. And then my larger numbers together, so my 18 over my 30. So just make sure, that's how you can figure out which ones to pair up together. So 9 over 15 reduces to 3 over 5. 18 over 30 also reduces to 3 over 5. So with my side angle side, since my angles between them, they are congruent, and both of my sides are the same ratio, so we can say yes by side angle side similarity. Our triangle ABC on the left is going to be similar to triangle DEC on the right. All right, so now for the triangle at the very bottom, I would say draw two triangles. So draw out two separate triangles first. All right, so you might need to push pause to draw out your two different triangles. So if you notice two different things, I had to add the 4 plus 5 and my 9 together for that left-hand side, and I had to add my 7 plus 14 right here to get my 21. So next I can compare my different sides. I don't have any angles, so the only one I can check for is it side, side, side. I'm just going to put a little question mark there. So I do need to check all of my different sides together. Remember, you want to pair up the smaller ones with the bigger ones. So the smallest in this first triangle is 13.5 with my 9. Remember, when you hit math, enter, enter, it reduces to 3 over 2. Next, I want to use the next smallest, so that would be my 15 and my 10. So 15 over 10 reduces to 3 over 2 also, so it's looking good. And lastly, my 21 with my 14. And that one also reduces to 3 over 2. So they are all the same ratio. So this means that yes, we can say the two triangles are congruent by side, side, side similarity. And the two triangles would be my triangle STQ is similar to triangle RUQ.